Organization: MedNova Health. Sector: nationwide healthcare network, spanning 80 clinics and 10 hospitals. Mission: use AI to detect early signs of chronic kidney disease, CKD, not after damage is done, but while it can still be prevented. North Star: catch what's silent. Never betray what's sacred. Chapter 1: the symptom that wouldn't speak. The crisis didn't come in a flood. It came in patterns, missed, misdiagnosed, and misunderstood. Chronic kidney disease, CKD, rarely screams. It whispers. For most patients, it's only diagnosed once significant damage has already set in. At MedNova, the executive team had been staring at the same heartbreaking data year after year. 7 out of 10 CKD patients were diagnosed too late. Yet the clues were there, scattered across lab results, buried in physician notes, hinted at in prescription histories. But no one system could connect them. And no doctor could sift through years of data in minutes. That's when the organization made a bold bet, not just to build an algorithm, but to reimagine how the entire system listens for risk. Chapter 2: rethinking the architecture, not just the model. They didn't want dashboards. They wanted a whisper in the doctor's ear, precise, quiet, explainable. A cross-functional coalition formed: AI engineers, enterprise architects, compliance leads, and clinical advisors. Their shared belief? We're not building a tool to predict the future. We're building an intelligent companion that notices what we'd otherwise miss, and speaks just in time. This wasn't just an AI problem. It was a systems design challenge. A trust challenge. A privacy challenge. And it required architecting from the edge inward, because the center wasn't safe enough. Chapter 3: anatomy of a listening machine. A listening without seeing. Federated Foundation's MedNova's hospitals were islands, each with its own electronic health record, EHR, system, formats, quirks. Unifying them was a pipe dream. So the team didn't try to centralize. Instead, they turned to FHIR APIs to standardize access to patient data. Then came the masterstroke: federated learning. The models would train locally, inside each hospital. The intelligence would move, but the patient data never would. To protect even deeper, they embedded differential privacy and k-anonymity into every analytic layer. I didn't need to know everything. It only needed to know what it was allowed to infer, and no more. Be hearing in multiple languages, multimodal intelligence. The medical record spoke in 2 dialects: cold, structured numbers, lab results, prescriptions, vitals, warm, human narratives, doctor notes, impressions, concerns. The AI engine respected both. On one side, a tree-based model parsed numeric trends. On the other, a fine-tuned clinical BERT read the messy, meaningful prose of doctors. The two were fused late in the process, never forcing one to dilute the other. Each voice retained its tone. The result: a system that could see patterns in charts, and understand the concern behind a doctor's phrasing. See, making the invisible understandable. Explainability at the core. A prediction is useless if a clinician doesn't trust it. Or worse, if they can't understand it. So the architecture didn't just output flags. It told quiet stories. Creatinine has risen 23% over the past 12 months. Urine protein traces plus history of hypertension suggest elevated risk. A risk score with confidence ranges, always visible. A timeline visualization showing progression, not just a snapshot. The interface wasn't built in isolation. Doctors co-designed it, sprint by sprint. This wasn't a clinical tool. It was a cognitive extension. Keeping intelligence close to home, edge deployment. Cloud was never an option. Each model was packaged in a secure container and deployed to hospital edge servers. Integration with the EHR happened through smart on FHIR plugins, seamless, secure, invisible to the clinician. Model updates didn't happen silently. They arrived with a changelog, in encrypted payloads, and with audit logs attached. The machine never wandered into black box territory. Every decision was traceable. Every insight was local. A feedback loop that learned, and could be questioned. MedNova didn't just want feedback. They wanted governance. Every prediction could be accepted, rejected, flagged with a reason. Those flags? Sent to a secure, de-identified vault, and reviewed monthly by an internal ethics board. If a pattern of misjudgment appeared, the architecture evolved. Not just the model, but the culture around it. If it can't be challenged, said the chief architect, it doesn't belong in medicine. Chapter 4. The Whisper That Saved Time and Trust. Within the first 120 days of deployment, CKD detection rose by 38% in early stages, trust score among clinicians hit 91%, measured not by opinion, but adoption, misdiagnosis dropped by 17%, as subtle signals found their voice. The platform expanded to diabetes. Then hypertension. But the real story? A patient didn't know a machine had helped. They only knew their doctor called sooner, ordered one more test, and caught something before it was too late. Chapter 5. Lessons for those who dare to listen. Design federated first, let data stay sovereign, and move the learning. Explainability is the interface, build it into every frame, not as decoration. Multimodal is the future, let each kind of data speak its truth. Trust isn't a metric, it's a system outcome.